Hello, my dear students. So let's discuss Pathfinder, check your understanding and challenge section. So in this chapter, challenge section is not there, but only 4 questions are there in check your understanding section. And these 4 questions are very important questions and good questions. So it's not like I'm saying that are too difficult questions to handle, but very good conceptual questions where you can learn many new things. So each and every question I will show you first. You try to do by yourself. Give yourself at least 5 to 10 minutes. Okay. So after that, if you are not getting idea, then only you see the solution, right? Please do not waste too much time in solving the questions. I have seen sometimes the students they put a lot of effort for doing questions in terms of energy as well as time, right? So maximum time allotted for any question is 15 minutes, beta. Maximum is 15 minutes, okay? So you are getting in 10 minutes, good only, but maximum time that you can give is 15 minutes. In 15 minutes not getting, then please see the solution, okay? Right. So that is our question number 1. An isotropic point light source S of power P located at distance d from a specially designed non-absorbing, non-dispersing and non-reflecting lens. Okay, this lens converges all the radiant energy coming from the source into a beam parallel to its optical axis. Find magnitude of force of radiation pressure on the lens. Okay, right, so pause your video here, try by yourself for 10 to 15 minutes and then see the solution. Okay students, now let's discuss the solution. Now here first you need to decide your approach, right? So what we should do in this question? So what they are asking, they are asking force of radiation pressure on the lens. So we know that any radiation is there that carries linear momentum also with them, right? So they carry what? Linear momentum. So if you are bending rays or bending radiations, then you have to apply force on them because you are changing their linear momentum. So because of this change in linear momentum, you have to apply force. So if you are applying force on radiations, then radiations will apply force on the agent, right? So now here that is required magnitude of force of radiation pressure on the lens. Okay. So answer is this. You can note. Now let's discuss it. So as I said, first of all, so here we should be interested in finding change in linear momentum of light due to its bending, right? So here a new thing now I am introducing with you. You might have already done this. So if it is new for you, then please listen very carefully. So force on light due to its bending is given by change in its momentum flow rate, right? So this term may be new for you, but it's very important. Momentum flow rate, right? So as we know, radiations they carry linear momentum. Derivative of that is momentum flow rate, okay? And direction of momentum flow rate is always along direction of propagation, right? So momentum flow rate, P derivative of momentum. Now linear momentum you can write energy possessed by a wave divided by C and then 1 by C dE by dt. Okay, so energy crossing from any point per unit time, you can call it power. So power associated with a wave divided by C into n cap. So that is what better? So that is momentum flow rate. So this quantity you just see, it is a very important physical quantity, right? So whenever force on radiations is required, just you write this formula. Final momentum flow rate minus initial momentum flow rate. That's it. Okay, no exceptional case to it. Whenever force is required, you just apply this formula, right? Okay. So now here capital P is what? Power associated with the beam, and cap is direction of propagation, right? So that is force acting on the beam or radiation. So this concept I am going to apply in the given question. So in the given question, if you see, now power of the source is given P. Now at the point where it is striking the lens, its power will reduce. Power will reduce means I am considering a small elemental portion where the light is striking, right? A small ring I am considering where the light is striking. So radius of that ring is x, and then small area associated with this I can write 2 pi x into r d theta. Okay. So now total power is P. Power per unit area is 4 pi r square, and the area where these rays are striking, this area is 2 pi x into r d theta. So this is what power associated with a small ring, elemental ring. Okay, this is small elemental ring. So here power striking, that I am writing. Okay, so it means linear momentum associated with it. Means x by r, you can say it is a sine theta, right? So power associated with it, you can write like this: P by 2 sine theta d theta. Okay, in this region only how much energy is striking per second. Now net force I want, beta. So net force is, now if you see here, so this same power that is bending in the horizontal direction. So its linear momentum is changing. So I want momentum, change in momentum flow rate I want. Okay, beta. So how much power is associated with it, divide by C if I am doing. So I will get momentum flow rate, right? But I know one component is what? Perpendicular to this line, means in vertical plane. So that is going to cancel with the symmetrically opposite element. So these momentums change will just cancel out. So net force what will get only in the horizontal direction, right? So final momentum in horizontal direction is just P cos theta, and initial is P, right? So then momentum flow rate final minus initial I am doing, beta. So net force, so P d theta, power in this direction, minus P d theta by C. So this change I am calculating. Now why I am writing this, beta, initial minus final? Because what we want in the question, force of radiation pressure on the lens, right? So on the lens means negative of force acting on the radiations. So force acting on the radiation is this formula, final rate minus initial rate, and negative of this. So that's why this I am writing first. Okay. So now this I am integrating from 0 to alpha. Alpha means this maximum possible angle, right, at the end of the lens. So this angle is alpha. Okay, beta. So then I am integrating the expression. Sine alpha you can write. So see, step by step you can see the integration part. Okay, and then by substituting the values I am getting the net force, right? So very important question. Any confusion is there, then please write in the comment section. Okay, don't worry. Now let's move to next question. So next question is very popular and important question, right? Now here something, small disclaimer is also there. So but this question, if you see in any online platform, right, so everywhere they are saying answer given in the book is wrong, but I am following some method and I am getting the right answer. So according to me, answer is 100% correct. So you just go through the question try by yourself and understand how I'm doing it. Suppose I'm doing any conceptual error, then please you are free to write in the comment section, right? In a respectful manner. So respectful manner you can write anything, beta. Hmm. So if any mistake I'm doing, then you can tell beta, right? Otherwise, question is very important, right? So if you see now the question is very simple. I will first explain you the question. So that is a cube, right? So what they are saying, when cube is at rest, this much amount of energy is released from it. Means this you are giving it. So obviously this much amount will be released from it, right? So one phase in black and all other are what beta? White. So it means what they are trying to say. So only from black surface radiations will come out, right? So solution of this question is a little bit big, okay, because I'm trying to solve this question from all different angles, right? So you need to note down, so what step by step I'm telling. So many concepts also I will tell in these questions. Okay, so one is what? Painted black. So from here radiations are coming out. So obviously if radiations are coming out, so what will happen beta? The radiations they carry linear momentum, and then by linear momentum conservation of radiations and block, because initially the block was at rest, it means the linear momentum of the system is zero. Finally also it should be zero. So then block will acquire velocity towards left, and this velocity only we need in a steady state, right? Okay, so that is a question. So please first see, this is the answer. By my methods I am getting the answer. Okay, right. Okay, so step by step I will tell beta. So first of all, the approach. Now approach is, as I said, we have to use linear momentum conservation, right? Now the thing is, one second, disturbing, one second, this thing. Okay, yes. Now the thing is, here a new thing I'm writing, that is Lambert's cosine law. Okay, beta. So you may say see different names of this thing, but logic is the same. Lambert's cosine law, right? Now according to it, beta, if from any flat surface radiations are coming out, then normal to the surface like this in this direction, intensity of radiation is more, but at any other angle intensity of radiations are less, and the formula is I naught cos theta at any angle theta. Now some students were writing in the comment section that whether the new concepts you are telling are relevant to JEE Advanced or not. Yes beta, these concepts are relevant only. If not directly, then indirectly in some questions you can use the properties associated with it. Okay, so anything if it is coming in Irodo book, Pathfinder book, it means you can consider it is directly or indirectly associated with your JEE Advanced syllabus. Okay, that is my recommendation. Otherwise your choice, your life. Okay, now beta, so if intensity normal to a surface, I am saying it is that is what I have explained. So at any angle theta normal to this surface, intensity is this, right? So that is Lambert's cosine law. So derivation is also there, right? So that derivation you can check. It is available in different sources. Now what I am writing for this intensity, the same thing you can write for energy per unit solid angle, because that is also the distribution of energy, right? So from this surface, if I am saying energy per unit solid angle is E naught, right, normally, then for any at any angle theta, so then if you form a solid angle, a small solid angle if you form, then energy per unit solid angle at any angle theta can be given by this relation. Okay, bete. Now solid angle you can write for any angle theta, it is 2 pi 1 minus cos theta, right? So solid angle formula, and any small angle solid angle derivative you are getting this. Okay. Now if dq is energy through solid angle d ohm, right? So as in our question total energy emitted was q. Now out of it, if only through solid angle d ohm energy emitted is dq, so it will be what beta? E naught cos theta into d ohm, because this expression was energy per unit solid angle. Okay, right. So now this dq I can integrate. So if I am integrating, you can see the step by step integration procedure. So total heat emitted is q is equal to pi e naught. So q here our case is 900, right beta? It means we are kind of getting e naught. So this e naught we are getting. Okay beta? So E naught we can write in terms of Q. So Q by pi means the total energy emitted per unit solid angle normally, that we are getting beta. Okay. So now I am talking about linear momentum. Linear momentum is energy upon c, right? So at any angle theta, horizontal linear momentum. So as I said, no beta, we are going to do linear momentum conservation. So I am interested in linear momentum in horizontal direction, right? So this I am writing, so dq by c into cos theta means energy possessed in any solid angle dq upon c cos theta, that is the linear momentum associated with the rays in this solid angle, right? And it's a horizontal component, right? So now net linear momentum in horizontal direction I am writing. So already we have obtained E naught in terms of Q, that we have obtained. So Q by pi c. So this again this integration you can see, right? So beta what I am getting, this is a very beautiful expression I am getting. PH is equal to 2Q by 3C, right? It means horizontal linear momentum of rays is equal to 2Q by 3C, right? Depending upon how much energy is emitted from a surface which is at rest. So from here, if Q energy is emitted, so then linear momentum of rays will be 2Q by 3C. Again, now linear momentum into C is what beta? Energy. So it means if Q is total energy emitted, then energy associated with all the rays having horizontal linear momentum, means linear momentum is a vector quantity, na beta? So I can just assume that from a surface, if rays are going out, so I can assume some rays are going directly horizontal, some rays are going directly vertical, like this. I am resolving these linear momentums. So then energy associated with all the rays which are coming horizontally, right? Means the components basically. So that I can write, it is 2Q by 3. So that I am calling it QH. Means energy associated with all the radiations which have linear momentum in horizontal direction. Okay, that is 2Q by 3. Right beta? So this is a very important thing now. So that you can say it is a 1. That is relation number 1. Now a separate thing that I am showing you here. Suppose we are saying only energy is associated with a particular photon in horizontal direction. Then terminal velocity of a body will be this. So QH is energy emitted. Now separately I am showing in the horizontal direction. QH, so total energy emitted will be energy of photon plus the kinetic energy of block. Now its linear momentum must remain conserved beta, no, horizontally. So this P I am writing m into V. Okay, and then I am solving it in terms of, you can say QH I am solving. So then using binomial theorem also. So in the answer key also they are writing this equivalent. So equivalent is equal to this in answer. Means they are also might be doing binomial expansion. Okay. So V I am getting it QH by 2mc. So that is point number 2. So now this QH you can write in terms of total energy emitted. So here I am writing it. So then from 1 and 2 I am getting V as Q by 3mc. So total energy mc total values if I am putting, then I will get 0.25 millimeter per second. Right. So like this we are getting the correct answer. So please see many different methods we are discussing here. Very important things are there. You can just correlate them. So individually also these concepts can be very useful in questions. Okay. So it's a multi-concept questions. Okay. Now let's move to next question. Question number 3. Okay. So this question I can say a bit easier question. Again multi-concept concept of cross electromagnetic field and hydrogen spectrum they are using, right? Now let's first understand the question. They are saying in the emission spectrum of hydrogen like ions, energies of spectral lines range from minimum value to a maximum value this. So now in hydrogen like ions, suppose the atoms are excited, means electrons are excited to some state. So when energy emitted will be minimum beta, when they are doing transition to just next level, means from n to n minus 1. And when energy emitted is maximum, when they are doing transition from n to the ground state. Hai. So photons of the second line of Barlow series are filtered. So that is minimum energy, that is maximum. So many different types of photons can be there. From that we are selecting second line of Balmer series. Okay, bete? And that are made to incident on the surface of metal of work function 2.2. So this energy, so whatever energy we are getting of Balmer series that you are filtering out and striking on a metal surface, work function is 2.2. It means this much energy will be consumed, remaining energy will be taken up by electron, photoelectron, and that photoelectron they are saying pass undeviated. And in cross electromagnetic field we know for any charged particle to pass undeviated, then QVB should be equal to QE, right? So or you can say V is equal to E by B. So next part is very simple, no problem. Okay. So here now approach is what beta? Approach is the same only. In hydrogen like ions, we need to first find Z using minimum and maximum energies, right? So minimum and maximum energies they are saying. So as I said, minimum energy means transition from n to n minus 1, right? So two closest this shells levels, so whatever transition is happening, so in that energy difference is minimum, and maximum energy will be from n to 1, means when the excited state electron is coming to ground state. So these two equations but I am using, I am dividing, okay, rearranging. So after rearrangement I am getting this kind of expression, right? So now you know good students are always better than physics teachers in calculations. Okay, so you can substitute different values of n, since we know n is an integer, right? So easily, or you can say quickly, we can get this value of n by hit and trial method. So n you are getting 5. Okay, so after getting n 5, you can use any of these equations, right? So from this equation n you are putting 5. So then what you will get, z is equal to 2. Okay, bete. Now z also we got. Now energy of second line of Balmer series, means from 3 to 2 first line of Balmer series, 4 to 2 second line of Balmer series, right? So energy associated to second line of Balmer series we are calculating. This energy is coming out to be 10.2 electron volt, right? So it means kinetic energy of photoelectron is what? 10.2 minus 2.2. 2.2 was work function. That is the kinetic energy of most energetic electron, right? So from kinetic energy we can find out velocity also, right? half mv square ke. So this you need to convert into joules. 8 electron volt into joules I am converting, mass of electron, right? So as I said, in cross electromagnetic field, for any charged particle to pass undivided, QVB should be equal to QE. So from here what I am getting, beta, E is equal to V into B. So this is perfectly matching with the answer given in the book. Okay, beta. So any confusion is there, any doubt is there, please write in the comment section. No problem. So okay, so slightly my answer is deviating. Maybe I'm not doing the calculation properly here. Okay, so that you please take care. Okay, now next question. So next question is basically looking very big. So now, but sometimes you see students feel that questions are very big. Who will read that big question, right? So let's leave that question. Sometimes in a big question, small concepts are there which are very helpful. Okay. So although conceptually this is a easy question, but step by step you see there can be few things which are very helpful, which can be very helpful for you. Okay, beta. Now, if you see the question, set of reactions are given to you. That what reactions are taking place in sun according to them. Okay. So like proton, two protons, they are combining, they are forming X1 and positron is coming out. Okay. So reaction 1, reaction 2, reaction 3, 4. Now after reaction 3, so we have two sets of reaction. They are calling it PP1 or PP2. Means the thing is hydrogen is getting converted into helium, right? And this reaction can happen by following two different sets after reaction 3. It can follow PP1 branch or it can follow PP2 branch. Okay. So these reactions are given to you. Now in A part, so that is identify X1, X2, X7. So these particles we need to identify. So this can be simply done by charge and mass balance, right? How you are doing in chemistry. Okay, the same thing. So same thing I also have done. Okay, any mistake if I have done, then you can write in the comment section. Okay, beta. So like 2p, so this positron is coming out, and then I'm doing what, charge balance and mass balance. So what I'm getting by charge balance, I'm getting here 1. So hydrogen with mass number 2. Okay, so 2H, deuterium. Now X2 is what, beta? Neutrino, because it is a conversion of a proton to neutron, right, beta? It is a conversion of a proton to neutron, right? So because two protons are combining, so this if this charge is leaving, that is without charge, proton means what? A neutron only, na? And by this a neutrino also ejects. That is a theory part, right? So similarly, like this in reaction 2, it is given like this. Now proton is combining with X1. So X1 I already identified, 2H, right? So 2H. Now mass balance and charge balance. So what charge, beta? 2. 2 protons and mass number 3. So what we are getting? Helium, right? So like this, step by step, 3 reaction, nothing is there. Now in reaction 4, now this X is the energy released, that we'll find later on. So now here what you are doing, so 2 helium are combining to form 1 helium and 2 hydrogen. Okay, so this I can identify again by charge and mass balance. So everywhere I am doing the same thing, beta, right? So here also same thing. So basically by charge and mass balance I am getting everything, right? So finally we are getting these 2 helium particle. So X6 is lithium, right? So we have identified all the particles. Now after that I have directly written the 7 reaction. Okay, so these 7 reaction now I have written. Okay. Now beta, for B part I have written those 7 reactions separately. They are saying find energy released during the production of one helium nucleus. Means that they want some kind of reaction where final product is a helium, so that we can write some reaction and we can find out the energy release. So mass of electron, so it is given. So means mass into c square if I am doing, so I can call it mass energy. Hamda. Similarly, this mass energy I can call like this. So that are given. So now here we need to do brainstorming that how we can obtain a reaction where final product is helium. So like this also I thought, right? So we have to do brainstorming. Then following PP1 branch, we can get a net reaction like this, right? So where we can find out the final product as helium, 2 neutrino. So this reaction we can obtain, right? By just thinking, right? So thinking different. First you can write, first you can just add. Means how I am getting this net reaction beta? I have just added this, right? So reactions from 1 to 4 I have added, right? So adding these 4 reactions I am getting this. Now in any other question there can be some other thing. You have to brainstorming by subtracting 1 from 2, 2 reactions from 3 like this. So by adding this first 4 reaction I am getting this reaction, okay, which you can call an equivalent reaction of first 4 reaction, right? So now I am getting the process how helium is forming in a short form, and then here I am writing bonding energy equation. Okay, bete? Right. Now part C was very easy, so we need to find X. So mass energy of reactants minus product. So product is what beta? Neutrino, massless. So directly I am getting, no problem. And similarly, net reaction from part B that you can use this reaction to find Y also beta. So Y also you can use. So because this I am keeping as a variable, right? So our Y was basically here. Y was present in reaction 4, means energy release in reaction 4. So in our equivalent reaction R4 is there, beta. So plus R4, so automatically Y will come. So this energy reaction I am using for part B, from part B, okay. So this I am getting, right. Now D part is interesting. So in this they are saying, so reaction 6 is the following in this manner, right? But it cannot happen like this. So means what is the condition associated with the Z? That is what they are saying, beta. Now we know why any reaction cannot take place, right? First of all, why any reaction can proceed? Any reaction can proceed when it releases net energy, means exothermic reaction. When we have an endothermic reaction, then obviously we need energy, so it is not a favorable reaction, so that is less likely it will proceed, right? So now what reaction they are giving? First of all, the actual reaction, what is happening? So this Z I am writing in terms of mass energies. I am writing this Z, that is our reaction 6, and the reaction which is not taking place, this. So then obviously mass energy of this should be lesser than this. That's why it is not taking place. So mass energy of this reactants should be less than mass energy of products, that I am writing beta. So this is I am calling R-6, and then I am adding these two equations. So what I am getting beta? I am getting a condition that Z is less than 1.02 electron volt. So that is our D part. Okay. So now E is, now actually E question is solved in the hint section only, in which the above reaction energy carried by any given product has unique value every time the reaction occurs. So beta, every time the reaction occurs, then energy carried by any given product has unique value. It means beta, energy distribution has to be same. Now if in the product we have only 2 elements, then we know initially the things are at rest, finally linear momentum has to be same. So if we have only two products, then energy distribution has to be same, means the amount of energy which are releasing, how it will distribute among the elements. Then you should have a unique way when we have only two things in the products. But if you have more than two things, like three or four things, then to make net linear momentum zero, we can have any method, is any arrangement. So in any way you can distribute energy among three or four elements which are making net linear momentum zero, and which are totaling total energy as energy released. Okay, so that's why we have to see in which elements we have finally two products only. So the reaction in which we have finally two products only, that is going to be our answer. Okay, bete, right? So that is our E part. So these only four questions were there, but all the questions are, I said, very important, right? So anything if it is not clear, please tell me, bete. Go through this question in detail, right? Okay, all the best. Thank you, beta. Next week again I will come up with next week's syllabus. Check your understanding and challenge sections. Okay, thank you.